Today we're talking about bivariate analysis. You guys are going to be able to create scatter plots, find correlation and regression lines of bivariate data, which basically concerns the relationship between two pairs of variables. Okay? Yes?
You misspoke bivariate. Why?
You know what? Fuck this. Scatter diagrams. Okay? They're also called scatter plots, and they're used to investigate possible relationships between, shut it up, two variables that both relate to the same event, okay? Basically show you how much one variable affects the other. The relationship between two variables is called their correlation, all right? And our scatter plots are basically drawn just like other line graphs where the independent variable is on the horizontal axis and the dependent variable is on the vertical axis, okay? So just like any old graph. Correlation is a way to measure how related two variables are, okay? It allows us to make a prediction about one variable based on what we know about the other. And you can have all different types of correlations. You can have a negative correlation where your data is going in a negative direction. You can have no correlation at all where basically your data is all over the place. There's not a relationship between your two, such as body color of a car versus its quality. Or you have a positive relationship where it is increasing as one increases, the other one increases, i.e. your auto insurance cost is going to increase with the number of accidents that you have. New drivers, that is the truth. You can also have different types like linear, where your data is going in a line, non-linear, where it kind of forms different types of curves, such as a exponential type function or a quadratic type function. You can have strong correlation, where your data is really close to each other heading in a positive direction. You got a strong negative, where it's all really close together heading in a negative direction. Weak, more spread out. Moderate, not as strong, not as weak, but somewhere in the middle. And you see none as well as a weak negative. Okay? The only one not seen here is a what? A moderate positive, which basically would be this graph just heading in the positive direction. They were straight, okay? And here are a few other. Now there is a number associated with the type of correlation that you guys have. We'll talk about that once we get to that part, the Pearson product correlation coefficient. But here are a few others. And in the sense of being strong, moderate, or weak, is basically as you draw the line of best fit, how close is the data to that line? That's why A is strong, B is still strong, C is more moderate, and D is a weak correlation, okay? You've seen this before. On your midterm, you guys remember this problem? Oh. So when it asks you which two of the following expressions describes the correlation between X and Y, what should you all have said?
Linear and strong negative.
Linear and then strong negative, okay? It definitely is not perfect. A perfect correlation would be what, you think? Almost like a straight line. This clearly isn't zero because it does form in a particular direction. It's not positive, so that took out all the positives, and it definitely was not weak. So those were your two answers for that one. Okay? Now, causation is a correlation between two data sets, not necessarily doesn't necessarily mean that one causes the other. For example, the shoe size of like middle schoolers, okay? And students' vocabulary have a strong positive correlation. The larger the shoe size, the larger vocabulary the student has, okay? Now, clearly we can see that shoe size and vocabulary have nothing to do with each other, but they are highly correlated. The reason why, their age. The older you get, the average student, I'm not talking about your high-level thinking student, I'm talking about your average student, the older you get, the bigger your vocabulary is, and of course, the older you get, hopefully you are growing, meaning your shoe size is getting bigger. Okay? So, question?
So you just said causation doesn't necessarily mean that one causes the other? I thought that's what causation means.
It means it's more of a correlation between the two, but doesn't necessarily mean that one has an impact on the other. Not always, not necessarily. And here's an example that relates to that. Okay? Now, you have an example where you have your data, you have to describe the relationship, the type of correlation, the strength, and whether it's linear or non-linear. Pretty simple. You plot your data, and then you examine, okay? So everybody right now, let's go ahead, let's plot our data, and then I want you guys to comment on the type and strength of the relationship. All right, so when you plot this data, all right, so we have our data. Is the relationship linear, nonlinear? Linear. And what is the type? Describe it in the strength.
Strong.
It is strong. And it is positive. Very good. Simple enough, yes? Let's go to the next one. Okay? The line of best fit can be used to make predictions. There are two different ways they may ask you to do it. It may ask you to draw it by eye. By eye basically means you find the mean point of x and y. So you find the mean of your x, find the mean of your y. And you're going to plot that point and draw your line through that point. As you draw, you want to make sure that half your data is above the line, half of your data is below the line. Okay? So that's how you draw it by eye. You find the mean point and then plot it and draw the line through it. Okay? So we have a relationship between the grams of fat and the total calories in fast food. We need to see if there is indeed a what's the line of best fit. We're going to draw a scatter diagram. We're going to find the mean and of fat and of the calories. How do you find the mean of either of these? Add them up and then divide it by the number of items. You do that for your fat and your calories. And you also need to plot this data. Okay, I want you guys to do that. Find the mean of both and then plot your data. And we'll come back to do part B. Yeah, okay. Alright, so we had to find the mean of the data. You added it up and divided by, these were 11 pieces, so what you get for the mean? 22.5, yes? And then you did the same thing with the calories, added it up, divided by 11, and you got 257? 457. And so you constructed your diagram. I have that already in my blue. Now it says plot the mean point on your scatter diagram and use it to draw the line of best fit. So you go to 22.5 on your x, you go to 457 on your y. And this is how you do it if you do it by hand. You draw the point for the mean. You circle it. And then you label it with an M. That is how you draw it. That's how you plot this, draw this by eye. So you put the point for the mean, you circle it, and then you label it with an M. And now when you draw your line of best fit by eye, you do the best that you can to place it so that your line goes through your mean point and half your data lies above it, half your data lies below it. So roughly, I have 1, 2, 3, 4, 4 above, 1 on, and about 6 below. That's the best I think I can do. Okay? And there you go. You want to make sure that when you draw it, that it does cross through your y-axis. Now, not every line of best fit is going to go through 0, 0. Okay? Go through your origin. And I know some of you guys did start 200 down here, then it's going to probably cut looking like it is at 0, 0, when in actuality it's not, because technically 0, 0 will be somewhere way below off the screen. Okay? So, questions on that? Drawing it by eye, we're good? Awesome. Now, to find the equation of the line of best fit, it's also known as the regression line. Okay? So the line that we just drew is called the regression line, and it can be used for prediction purposes, like use the equation to predict something that's happening in the future or somebody else's scores. So you have 10 students out of 100, their final exam grades and their classwork grades. Carolina was absent for the finals, so we're not going to include her grades in finding the mean point. So to find the mean of the classwork score, we're going to add all these up and divide by what? Divide by 9, because we are not including Caroline's score at the moment. Okay, do not include her. And then also find the final exam score. Can you guys do that, please? The one thing that I haven't done, which is a no-no on my part, and I want to make sure that we correct it with you guys, whenever you have to draw it by hand yourself, please make sure that you label not only the axes, but you also put titles along your X and Y axes. So please make sure that you do title those graphs, the X and Y axis. What was the mean classwork score? including Caroline. And the mean final exam score, clearly not including Caroline. 72. So you go to 75, you go to 72, you have to plot it. You plot it, you circle it, you label it with an M. Okay? And then we are going to draw the line of best fit that goes through our mean point. Okay? So when we draw, we want to make sure that some of our data is above it, some of our data is below it. Alright, so we have our line of best fit. Yours may look a little bit different depending on how you label it, but make sure that however you draw it, it does indeed go through your y-axis at some point. Okay? Mine would continue on. I can draw that down, and so on and so forth. Okay? So now we have to find the equation of the regression line. Okay? It is a line. What is the standard form for a line? Y equals mx plus b. Okay? So we have to find our m, which represents our what?
Slope.
Which represents our slope. So when we do this, when we find our slope, we always want to use the mean point as one of our points, and then we want to use another point that is on our line. Now, when you drew your line of best fit, did it go through or did it get very close to any other point? If it went through 2, then cool, just pick one of those, okay? So pick a point that your line of best fit went through, and use that point in your mean to create your slope, okay? For me, I was trying to get mine so it could kind of go through. I'm gonna say it went through this one, which was 88. Okay? So, depending on what point it went through, you are finding your slope using the mean, okay? You guys remember old school slope formula? Right? As long as if you put y1 first, then you need to put x1 first on the bottom. As long as they match up, then you're straight, okay? So 85 minus 72 is 13 over 13. Okay? Now for me, I got a slope of 1. Some of you guys might not get a slope of 1, some of you guys might get something different, okay? But whatever point you use, you have to commit to that, and then you have to answer the next question based off of that, okay? So, I have my slope, and now to find my b, I'm going to use one of the points that is on my line, clearly the mean, okay? And I'm going to plug that in for x and y to find my y-intercept. So I use the slope I found for me, which was 1. Yours might be something different. Plug in 75, plug in 72, solve for b. For me, my y-intercept is -3, which makes sense. If I look at mine, clearly I'm going to intersect my y-axis below the x1, so it would have had been a negative value, okay? So my equation would be y equals 1x minus 3, and no, you don't have to put the 1, I don't know why I put 1. So, because part E says use the equation, clearly, that you got to estimate Carolina's score on the final exam. How do I do that? How do I figure that out? Plug in what? For x. So you plug in 80 for x, so that's 1 times 80 minus 3. So her final exam score based off of my equation would have been 77. Whatever you got as your equation, that's what you want to use. That's where follow-through can come into play. All right. Now, the regression line is another name for the line of best fit, clearly. Realize that the regression line describes how the data is related to one another. So, here's an example. A study was done to investigate the relationship between the age, x, and years of a young child can run 1 kilometer. The data from children between the ages of 7 and 18 were collected. The equation of the regression line was found to be this right here, 20 minus 1 half x. Sometimes they may ask you to interpret what does the slope mean, what does the y-intercept mean, okay? Clearly the slope is what in this problem? Negative. Okay, so our slope is equal to a negative 1 half. If we have a negative slope, that means our line is decreasing. To interpret that in your own words, you basically need to just explain what does that mean in context of the problem. You just can't say the slope is negative 1 half. You have to say in context of the problem, what does that mean? Yes?
The older the children get, the slower they are. Yeah.
Okay. So the older they get,
Faster than that, 'cause it's in minutes. That's when it's moving faster.
Oh, that makes
exactly.
sense. That makes sense.
Exactly. So this represents our time. So technically, the older we get, right?
Yeah.
The older a child gets, the faster they are. Now, the one thing I will say about this is I would use the numbers to go along with it. So, in relationship, okay, so the older the child gets, so
For every year they age,
for every year they age,
lose 2 minutes.
they lose 2 minutes.
Did I get that backwards? Yeah. For every 2 years, they lose 1 minute. It's gotta
Okay.
be one or the other.
Yeah, I know.
It is
So,
going to be one or the other. So let's put some numbers. Okay, the older the child gets,
Yeah. Otherwise, that wouldn't make any sense.
so as they age by, you're saying as they age by 2 years, they're getting
1 minute faster.
1 minute faster. Okay. What does the y-intercept mean?
That'd be the fastest time, or the slowest time.
Well, yeah, that'd be slow. Because if it's negative, the y-intercept
But it's just between 7 and.
That's true.
So
It is between the ages of 7.
It's nothing.
So technically, the y-intercept, you can say it means nothing. There's no relevance because the ages start. The data was collected from 7 to.
So you're telling me an infant can't run this thing in 20 minutes.
Oh my yeah, so the y-intercept would be unborn is 20 minutes. The time.
The unborn child.
Unborn or it's kind of or it's a woman currently getting labor.
Alright, do this one. Interpret the slope, the y-intercept, and then we'll take a look at what you guys say. So, what's the slope?
27 over 5.
True, because 5.4 does convert into 27 over 5.
How can I say there's 5.4 more birds for every 1 hectare?
True, if you do convert to a fraction, you can actually say, as you interpret that, what, for every
5 hectares, or 5 trees per hectare, there's 27 more birds.
For every 5 trees per hectare, there are 27 birds. What's the y-intercept?
8.
So then what does that mean?
Initial number of birds, 8. When there are no trees, there are 8 birds.
When there are no trees. Questions about that? Just make sure that whenever you interpret, you want to include the number that goes along with your explanation, okay? It's kind of like giving a justification without the math to support it. Alright, last little bit. The least square regression. Residual is the vertical distance between the data points and the graph of the regression equation. For exams, of course, they'll be expecting you to do this using your calculator. There is a way to do it by hand. For my folks who are using this, if you did anything of a graph, you're trying to see if things are related, you came up with an equation yourself, then I will post a video of me doing these examples by hand so you can see, because you'll be expected to do it by hand in your IA. But I am going to show you guys how to do it using your calculator, because that's how they expect you to do it for the
Real life.
exam. Okay? So here we go. Use your graphic display calculator to sketch the scatter diagram with the line of best fit. So everyone does need a calculator. If you don't have yours, go grab it. When you go to your calculator, your data needs to be typed in. So that means that you need to go to the stat button.
You get to the stat button. Stat.
And then you have to edit your data. So you go to stat and you go to edit. You should have L1 and L2 on your screen. Does anybody not have L1 or not have L2? Okay. If yours does not have it, and this is good for everyone because this can happen. Stop real quick. Everyone look at this. Say you go up and you want to clear out your tables. You want to press clear and click enter. That's how you clear out your table if any data is in there. However, if you accidentally press delete, your L1 is gone. You cannot pretend like L2 is L1 and type in your data. It will give you an error message. So this is how you get it back in case you delete it. You go to stat, you go down to option 5, which is setup editor, and you click enter. Okay? So that way when you go back to stat and click number 1, L1 is back. Okay? If you forget that, you can always reset the memory. Okay? You can always reset the memory if it goes away too. Alright, so what are we going to type in L1?
Distance.
The distances, and what in L2?
There.
The fair, okay? So you type in the information, click enter to get to the next line. Alright, so once you get all your data in, you want to make sure that that you have the same dimensions here. If not, you'll get an error message. Make sure you have L1, L2. If not, you'll get an error message. So it says that they want us to graph this along with the regression line. So there's going to have to be a couple of things that you're going to need to do. Okay? When you guys get your calculators on the day of the exam, the memory is reset. Okay? Which means everything's going to go back to its default mode. Okay? You're going to go automatically back to radians. Everything else in your y equals is going to be cleared out. All of your tables are going to be cleared out as well. Okay, so you're going to basically start with a fresh slate. So what you're going to need to do is to get the line, the regression line there, you're going to need to go to stat. You're going to need to go over to calc, and then you're going to go to option 4, lin reg. Okay? Go to option 4, lin reg. Now, when you go to option 4, raise your hand if your calculator looks like mine. Okay, please pay attention because, again, you do not know which calculator you're going to get. If yours looks like mine, then you want to make sure that L1 is in your X list and L2 is your Y list. Clearly, we put our distances in X and our fairs in our Y. Okay? Now, don't worry about frequency list. Okay? Something's there, just delete. Okay? It'll go away. Now, this store reg EQ. That basically means you're going to store the regression equation into your y equals. To do that, you press bars, go over to y bars, and click enter on function. Now here, you have your option. You put in the y1, y2, y3, it doesn't matter. For the sake of this, I'm going to put this into y1. Okay? And so when you go down to calculate, it gives you the equation for your regression line. You see that y equals ax plus b. A represents your slope, and here are the values for A, here are the values for B. Okay? Now, if yours did not look like mine, and it just popped up lin reg, raise your hand if it did that. Okay? So this is what you do. You have to press the second button. You have to press the 1 button. When you do that, L1 will pop up on your screen. Does it not?
I did it like, can't you also do like second stat and then click L1? Because it comes up like L1 and L2. It worked.
Yes, yes, you do that. Okay. You do have to make sure that you press a comma to separate the two. Comma is located right above your 7 button. Then you can press second stat, go to L2, or you can push second 2, and then that pops up in L2. Now you have to do another comma because just like how we had to store our equation in, you have to do the same. So you're going to go through the process. You're going to click bars, go over to y bars, go to option 1 function, and then pick where you want to plug your function into.
So we don't get that R stuff.
I will talk about that in just a second. Okay? When you do that, Y1 will pop up, and when you click enter, you should get the same results that I do. Do you? Okay. So, since part B does ask me to write down the equation of my line of best fit, can you guys read it out to me? Of course, rounding three significant figures is Y equals
0.117x plus 83.3.
okay. And this will be the equation that we use to estimate the cost of a 10,000 kilometer flight. How do I do that?
Plug in 10,000 for or not 10,000.
1,000? Go ahead and work this out and tell me how much it's going to be. We are talking about money, so of course you want to make sure you round the two significant figures. Now, it does say use your graphic display calculator to sketch the scatter diagram. So we're going to use our calculator to sketch this. Everybody up to date with me? Caught up? Don't worry about the R. I'll talk about that in the next example. Okay? When you go to Y equals, there's your equation. It is sitting in Y1 or Y2, whatever you chose to put it. Okay? For me, I chose to put it in Y1, so there it is, the whole thing, not rounded, the whole thing there. Now, in order to graph our scatter diagram as well as our regression equation, you need to go up to plot 1, and you need to click enter. Enter basically turns on your scatter plot. It allows the calculator to graph the data that you put into your list. And now to actually graph it, you'll click zoom, and you go down to option 9, which is stat. And there is your data, and there is your line of best fit.
Oh, real Jesus. Wow. Wow.
You can also use this option, say you have some time left and you want to kind of make sure you did a good job on your scatter diagram and your line of best fit by eye. You can, and it's a calculator type problem. You can type your data in, do the same process, and you'll get a good idea. Yes?
Is there a way to find the actual line of best fit equation without using the calculator?
Yes. That's what the other video will be, and I'll show you how to do all that by hand.
Is it like to find without the calculator? Is it like using like the standard deviation variance stuff?
Yeah. And so it's to do it by hand. There are a good number of steps. The way I do it is I put it into a nice little table because I need like the totals of a lot of things. All right. Last bit. Measuring correlation, okay? The Pearson product moment correlation coefficient, denoted by R, is a measure of the correlation between the two variables. The value is always between 1 and -1 inclusively. Remember that problem for the midterm when it asks you what the values R can take on? It's -1 to +1. It is widely used in sciences as a measure of strength of the linear dependence between two variables. So that R that was on my screen, that if you didn't have, I'll show you how to get it. Basically, it's going to tell me whether or not I have a weak correlation, a very weak correlation, a moderate one, or a strong one. It's going to basically give me a numerical value to help me determine whether or not it is strong, moderate, weak, or very weak.
And is it just flipped over the other ones?
And it is just flipped with the other one. So if it was 0 to -0.25, it would still be very weak. It would just be a negative correlation. So it also applies to the negatives. Okay? So, to find it by hand, this is the formula. I will go about doing all this in a separate video.
I did that equation, but can you type it out? Like, if you type out all the steps to it, or do you actually have to
Well, the way that I would do it, if I was doing it for an IA, what I would do is I would basically create a table that has all these numbers. Like I would have a column that has all my X's, and then at the bottom I would have the total to represent that number. I have all my Y's in another column with the total. And then I would basically take those totals somewhere in the body of my paper, multiply these, divide it by n, and have whatever this number is. Like I will put it in a table format instead of
a lot
actually
of stuff on Excel, like,
yeah.
but it takes forever to type everything.
Yeah. this is the equation to go for regression line by hand. So it's the same x s sub xy, that's the same here, and the s sub x is the same thing. The x bar and the y bar mean the same. So, using your calculator, we're going to do this example, and this is up here just for the sake, because I'm going to do this by hand after you guys leave. So don't worry about the table, that's for by hand. Alright, so Sue wants to determine the strength of correlation between the number of spoons of plant food she uses and the extra number of orchids grown from the plant. We're going to use the, we're not going to use the formula, that's what the second video is for, but I'm going to show you how to do it using your calculator, okay? Now, when you get your calculator, when it gets reset and everything like that, your correlation coefficient is not turned on. So what you need to do is you need to turn it on. And it won't be when you get your calculator the day of the exam. So this is what you need to do, okay? You'll need to press the second button, and then you'll need to press the 0 button. And it takes you to a catalog. Catalog is also a place you can go, say you forget where normal CDF is, you can go to the catalog and find it, okay? So it's kind of like one of those, I forgot where this is, I can go to the catalog to find it. But I want to go down and I want to turn my diagnostic on. So I'm going to press the X to the -1 button. It's going to automatically take me down to the D's. Okay, and as you see those little green letters above, there's your alphabet, so you can jump to other letters. And it's automatically on your alpha. So I'm going to scroll down to where it says diagnostic on. And I'm going to click enter to turn my diagnostic on. Okay? Now, my diagnostic was already on, that's why my R showed up for that last example. If your R didn't show up for the last example, that means your diagnostic wasn't on. But if you did this, it should be on now. So now we're going to find R. We got to go back, we got to type this data into L1 and L2. Where do I go to get to L1 and L2? Stat, edit. How do I clear my data? Clear enter on L2. And on L1. And what am I going to type into L1? 1, 2, 3, 4, the spoons of plant food. And what am I going to type into L2?
Increase the number of orchids.
The number of orchids, which were
2, 3, 8, 7.
2, 3, 8, and 7. Okay? And now to find my R, I got to go back through the process of getting my linear, my regression line. Okay? Which was what? Stat. Over to the right,
Down to 4.
option 4. And as you see, my X list is in L1, my Y list is in L2. If yours does not show up, you have to do L1, L2 again.
The default settings for it means if you just hit enter,
Yeah,
just store it, but it'll get the data.
Even with the L2.
Yeah, it'll get the L1 and L2 is automatic, but it won't store it.
Now we don't need to really worry about the regression line because it only asks us for the correlation coefficient. If it did ask for it, of course we go through the whole process of storing it. But we're going to go ahead and calculate. There's our equation. Did everyone get 0.877? So there is our correlation coefficient, meaning that the relationship between number of plant food and the number of orchids is strong. Not only is it strong, but it's also positive. Do not just shorthand and say it's strong. Make sure you at least describe it with 2 of the 3 things. Okay? It's strength, it's direction, and a lot of times the data that you are going to use is going to be linear. Questions?